rational function. It looks like this. F of x equals P of x over Q of x, right? A polynomial divided by a polynomial. Just kind of three different parts we want to look at. So my zeros in the numerator. Right? The zeros of P of x, so the values that make P of x equal 0, the values that make the numerator equal 0, the zeros of P of x give the x-intercepts of the function. X-intercepts of f of x, right? So again, when I have zeros in the numerator, when I have 0 in the numerator, that's telling me the x-intercepts. And why is that true? Because if the numerator is 0, the whole function is equal to 0. And then my zeros of the denominator, zeros in the denominator, so the values that make Q of x, the denominator, equal 0. So the zeros of Q of x give the vertical asymptotes of the function. Bless you. Right? The values that make the denominator 0 tell us the vertical asymptotes. And why is that? Because, bless you, the denominator cannot equal 0. Right? It's undefined. And then whatever, if there's going to be a 0 in both the numerator and the denominator, zeros in both, right? So a value that makes both P of x and Q of x equals 0 creates a whole. And again, why? Because you can't have both an x-intercept and a vertical asymptote and an asymptote at the same value of x. When I have that same factor in the numerator and the denominator, the factor will divide out, cancels out.